Mic check, I'm good. So I'm Max Ceron, CWB Association Welding Podcast. Today we have a really cool guest, Welding Podcast.
The show is about to begin.
All right, and welcome to another episode of the CWB Association podcast with me, Max Ceron. Today's guest, we got a young and upcoming intellectual master called Robert Moser. I had lots of fun with him years ago when he was a student, and now we have him on the show to talk about some of the cool stuff that's going on in his world. So, Robert, how you doing this morning?
I'm doing great, Max. Thanks for having me.
It was, I've kind of been keeping track on what's going on in your world. I find that it's interesting kind of keeping tabs on what's happening with my students, and lots of students are doing really cool things. And, when were you in the welding program? I guess, how old are you right now?
Right now, I'm 22 years old. And so I was in the welding program when I was 18 years old. So that would have been 2017. Yeah.
Yeah, so you just right out of high school basically went into the welding program. And
Yeah.
what was the deciding factor to get you into welding? Because I feel like you probably did okay in school.
Oh, yeah, 100%. I did very well in school. Welding was just always something that kind of interested me. Even as I was a young kid, my grandpa was he told me, he's like, yeah, you could join these two pieces of metal with a welder. I'm like, you can what? It just kind of fascinated me. I didn't even think that was a possibility, but I would have been very young at the time. So I was like, I want to try that. I never really got the opportunity to try it. And then what really got me into welding was I went to Miller High School. And so at Miller, they have a welding shop there that you can actually, it's probably one of the best welding shops in Regina. So I went there, and obviously I wasn't that great at it when I started. Your first speed's probably I don't know, an eighth of an inch, and traveling a million miles an hour. But so I started welding at school, and I just loved it. Then I ended up getting a job welding, and I just loved it. Welding is just something that I just kind of love doing. So
that's a super interesting thing, because there's kind of an idea that welders are all these guys that don't do good in school, and you kind of fall into welding as a last resort. And myself, I wasn't part of that train. I'm educated, and
Right.
there's lots of really well educated welders that they're kind of coming at it from a different angle, right?
For sure.
When you came in, I remember talking to you right in the beginning of the semester, and you were very vocal about having kind of a plan. You wanted to get your welding under your belt, and then you kind of wanted to move on. So you came out of Miller High School, which I think just got awarded a student there got a prize from the CWB Foundation, I think. So the Miller program is great, and you came out of there. You came to Sask Poly, right out of high school. And then what did you think? Day one of school, you're coming into a college, maybe not the college that your parents or family members thought you were going to be going to, but a college nonetheless. What did you think about it?
Well, I don't really know if it was a college that my parents didn't think I was going to, because it was we did have the discussion, and they're welding is it's never a bad choice to go into welding, because for one, my end goal was to do more schooling, engineering, right? But if I engineer stuff and I actually don't know how it's actually made, then you're going to be causing a lot of problems.
Yeah, there's going to be a big disconnect there.
Yeah, for sure. And so going into Sask Poly, what your question was what was my first thoughts on it? Is honestly, it's kind of like you're right out of high school, so it's you're almost intimidated. It's oh man, there's adults here. I'm just a little kid, that's how it kind of feels, because I'm 17 or 18 years old, and there's people who are 28, and it's kind of intimidating. But once I actually kind of got into it, then it becomes a little more comfortable, and it's this is actually pretty awesome.
Yeah, there is always a really interesting intake of students every year. It's one of the funnest parts of the school year is like that first week. Not just because you're getting started, but you get to meet a whole crop of new students. And you got the 18-year-olds right out of high school. They're wide-eyed and scared. And then you got like the 30-year-olds or 40-year-olds, or right just this week I had a 51-year-old student, and they got a different take on it. But everyone's there for the same reason, right? Everyone's there because they want to learn how to weld.
100%, 100%. And you actually like you don't like you learn things about welding, but you also learn things about like, okay, well now I'm an adult. We're kind of like on the same level. It's not like like
Yeah, they're
you
not
kind of
like
get some
ahead of
mutual
you.
respect.
Yeah.
Yeah.
So how'd you do in the welding program? You were a pretty good student, weren't you?
Yeah, I did pretty well. I was I took part in the skills competition and I got second in the provincial competition.
Yeah.
So that was pretty good. And I'm pretty sure I was one of the best in the class that year. So I did relatively well.
Good. Who won that year?
Who won? Uh Adam Sebastian
Oh,
won, yeah.
you were in the class with Adam then.
Well, he won the year before me. Then
Oh,
he
right,
won the
right.
yeah, so he had a year up on me. So
You could
no,
have
I'm
come.
not jealous.
Yeah, you could have come back. You could have come back. I mean, he got to go to Russia last
I
year.
know.
Adam really ran with it, and that's good, right? That's a good thing.
I know. Yeah, he's a wonderful welder for sure. Yeah.
So you finished your level one. I think you were in the were you in the applied cert or in the preem? Like the long one or the short one?
8 months. I got my year 1 and 2.
Yeah, okay. So that's the pre-employment course.
Yep.
Who was your teacher?
Who was my teacher? Uh, Kevin was my teacher.
Kevin was your teacher. He just retired a couple years ago now. So
He did. Yeah, I think he retired right after me.
yeah,
That
so
was too much for him, I guess.
yeah, you wore him out. Trust me, there's students that make me want to retire too. So you finished school. Where'd you go work? Like you got a job right out of school?
I had a job before I went into school, and I worked full time during school too. So it was more of like a fabrication type shop. It was like a lot of sheet metal, some heavier projects too. I did a lot of like TIG welding, stainless steel, that type of thing. So it was a cool job. Then after school, I went and still welded a little bit during the summer, and that was kind of like the plan coming out of high school. The plan coming out of high school was okay. Um, I was thinking, okay, if I went right to university, I'd be completely broke, have no money, wouldn't be able to pay for school. But why wouldn't I just go and take a welding program? Like, because I like welding, and
Now you can make money. You have a money making
you can
ability.
make money.
Yeah.
Exactly. So
And
I
practical
made
skills
my
don't go away.
yeah, the skills you never lose that. Like you go back and I sit there and I start TIG welding, still, it's the same golden color I had 5 years ago. But but yeah, so
So you're back at your
I
job.
graduated. Yeah, I got lost there for a few seconds.
Yeah.
Actually my job. Yeah. Uh so I graduated high school, started that job, went to Sask Poly, did the job during Sask Poly, and then every single summer during like in between my schooling, I was also doing some welding and working my way towards my journey person. Yeah.
So did you get your journey person?
I was supposed to get it in the summer, but it got canceled because of COVID, so that was kind of unfortunate. But I should be going in September, so
Oh,
wish me luck.
oh, you'll do fine. You'll do fine. I know we have a challenge group coming in, I think, into one of the colleges next week. And those guys they got big cojones to come in and challenge. Challenging's tough. I challenged my red seals, and it was a hard go. I don't recommend it to anybody. I kind of recommend going to school. It makes more
Right.
sense.
Yeah, that would be pretty tough. Like you'd have to have all those down pat without any practice.
Yeah, well, I went in and got a booth for a bit just to get ready for it, but the welding one wasn't too bad because I had been welding for a while. But the
Right.
one that was really tough was my steel fab. I went and challenged my steel fab ticket, and that's a lot of intellectual. It's a lot of math, a lot of algebra, a lot of geotrig, and
Right.
and I studied my butt off, and I got like a 74. Like I passed, but it was
Yeah, right.
hard. And like I'm not used to getting 70s, and I was like very happy to get that 74.
It's probably one of those tests where it's like, oh no, I don't know if I passed,
Yeah,
right?
no, I walked out of there just sweating bullets, and I almost ran out of time, which never happens. Like usually I never have
Oh,
a time issue, but I was almost out of time, and that's when I realized like, wow, this is way harder than I thought it was going to be.
for sure. Yeah, I would not be surprised.
Well, that's awesome. So you're gonna follow through with it. You're gonna go through and get your red seal.
Oh yeah, 100%, no doubt in my mind. I'm gonna get it. Yeah,
Yeah, but right now, like as we speak, you're in Saskatoon
I'm in Saskatoon. Yeah,
because you're going to the U of S, right?
yeah, taking structural engineering. Yeah.
Okay, so you knew you wanted to be an engineer before you knew you wanted to be a welder, or did they get kind of
Uh,
hand in hand?
they're kind of hand in hand. Uh, I don't know if it's just I want to be an engineer. I kind of want to like use the two together. So like right now I'm really debating like do I want to like start a business like with a welding shop with my engineering background, so maybe I can like design some of my stuff in house and do like both the engineering or the welding. Is I don't know. I'm too young to know. But
Well, it's too bad that you like. I mean, it's just a matter of timing because you were here 3 years ago, and 2 years ago the innovative manufacturing program started up, and you would
oh
have loved
really?
it because it's welding, machining, engineering, design, research, all in a 2-year course, and it counts towards a degree in engineering. Like it's worth 1 year of engineering, so it's a new program
Oh
South
really?
Poly has that's super cool, and like a guy like you is what that was built for. You know what I mean?
Yeah, that would have been perfect for me because like here I like because like right now I'm part of the bridge design team at the U of S. So like I'm sitting here trying to make like bridge connections, and it's like a scaled down bridge, right?
Hmm.
So I'm sitting here, I'm like, oh, man, if I only know how to machine this part,
Yeah.
so that would have been so cool. I wish I knew how to machine.
Yeah, no, it's awesome. It's an awesome program. I got help. I was part of like the design team for the program. So it was a whole group of us that kind of saw what the industry was needing was guys like yourselves, academically, practically minded academics that want to use their intellectual side for the design and management, but also have a clear understanding of the floor, of the
Right.
welding process. And those engineers in your life that you work with that actually get welding or have welded or machined or been on the floor are invaluable. Like they're the
Oh,
best guys to
100%.
work with. Yeah.
100%. Like I was like just as an example, I was working with some engineers this summer, and some of them like you could just tell they had no like engineering experience, and it's like, so you want me to weld through that I-beam?
Yeah, and that's a lot of the problem.
Right.
It's something in the welding industry, and anybody who's listening to this podcast right now knows that moment when you get a blueprint in front of you and you're just looking at it thinking, God damn engineers, what is this? Like, this is fantasy. There's no way this can actually be created.
Yeah, and then you're stuck on your end, and you're sitting there. It's like, okay, well, I guess I got to figure this out.
Yeah. And in that innovative manufacturing program, one of the things that I do, which is really sneaky, and hopefully there's no next year students listening because then they'll know, is I give them blueprints, engineered prints for simple constructions for them to do as a project, and they're prints that AutoCAD or Inventor allows you to create because it doesn't have any conscience, right? So I
Right.
can
Yeah.
create these simple prints and give them to the students, and then they try to build them. But the trick is that they're unbuildable. They all have
Ah.
a fatal flaw, and each print has a fatal flaw that it won't allow it to happen. And so basically I give them this project, 12 students, and I kind of wait till the first person figures it out that they're like, wait a second, you can't do this. And that's the right answer. That's the trick. And some of them get it quick, some don't. Some, like I had a class where they worked on it for half the day being like, we can make this happen. We can make this happen. There's kind of a desire to make engineers happy. It's some weird,
Right.
unicorn thing in your head that you're like, this is an educated person. I should be able to make this happen. And I don't want to complain or cause a problem. But sometimes the print is just wrong, right?
Oh, 100%. And it's not the fact that they're unintelligent people. It's just that they're not experienced the same way that we're experienced, and they don't like realize like the actual construction side of it. Like they know the math, right?
Yeah. Another one that's really important with engineers, if there's any engineers listening, is material choice. This is a conversation
Right.
I just had in a buddy's shop on Friday last week, um, because he was kept getting engineers drawings. He's doing concrete form structures, and all the
Okay.
engineering prints for these concrete forms are like weird channel sizes. So it's C channels that go around this
Okay.
outside of a frame. And all these engineers prints that he's showing me these prints coming from the engineers, and they're all like 8 at 14 channel, 7 at 39. Like, yeah, AutoCAD says you can use that material. It'll give you a load design. You can do stress tests, the whole thing. But can you order that? Like,
Yeah,
is it
that's
actually a real material that you can order? And it's not. So you got to custom order the C channel now, and it's going to take 3 months
and
to
price
show
is
up,
gonna, yeah.
right? And so that's something an engineer will never know unless they actually have something to do with either the ordering or the building of a product, because the first thing you should do is contact your local steel supplier
Oh, 100%.
and see
Yeah.
what's available, and then
Yeah,
engineer
100%.
what's around what's available, right?
Yeah, and like even me, with work I was doing in the summer, like I had to order stuff, and I was like, I knew right away, like I'm not gonna just like design this with a C7 by whatever,
Yeah,
because like
some
what's the
mythical
chances they're gonna
metal.
have that? Yeah, and I did call. They don't have C7, so
No, it doesn't exist. No. I mean,
it
someone will probably
exists,
make
but
it.
you got to get it from like the States, and it's gonna cost 3 times the price, and it's like, yeah, we could just go to a C8.
Yeah, exactly. All right, well, man, that was 15 minutes already. So we're going to take a big, quick break here for the sponsors. So I hope you guys are enjoying the podcast. This is the CWBA podcast here with Robert Moser, and we'll be right back.
The CWB Group is offering a hydrostatic testing course at our Nisku CWB training facility. This course is a must-have for all personnel involved in the planning, execution, and inspection of hydrostatic testing. It ensures that everyone involved in any given hydro test will have the same baseline training and safety protocols across Canada. This course covers a wide range of topics related to pressure testing, with a specific emphasis on hydrostatic testing of oil and gas pipelines according to CSA Z662 and other applicable Canadian regulations. The 3-day course covers the theoretical background and practical aspects of pressure testing. The hands-on practical exercises are unique to this course, and individuals will learn how to calculate different variables related to hydrostatic testing. Course highlights include testing theory, establishing the safe pressure test requirement and environment, test setup and sequence, test instrumentation and documentation, practical demonstration of pig launching and receiving techniques, practical demonstration of burst test. Space is limited. Register today for the first Canadian-focused hydrostatic training course.
All right, and we're back on the CWB Association podcast. I'm Max Ceron, and we're going to continue on with Robert Moser, a welding student who's in his second year for welding. And what year are you for engineering, structural engineering at the U of S?
Well, I'm actually in my 4th year because I do have all the hours
Mhm.
for welding, and I'm also in my 4th year for engineering. Yeah.
Okay, so this is your last year of school. You graduate in June then, or?
Yeah, I graduate in June, all done.
That's fun. And then, like you said, you got some big choices ahead of you.
I do. Hopefully, with the way the economy's looking, I don't know, but like I'm doing well, so.
Yeah, it's all right. You know what? Don't worry about the economy. Young guys, you guys are fine. I mean, what's happening is there's a lot of trimming of the shaft, and it's all us old guys getting cut. So it's all right. You guys are fine.
Well, when you put it like that, it sounds better.
And it's, it's good. It's, I hate to say it, but dark times, tough times create lean machines. So what happens is
Oh,
a
right.
lot of companies are having to learn to diversify and expand properly and retrain, and none of those things are bad. You
Oh,
know.
no, definitely.
All right.
Definitely.
So what are you doing at the U of S? You must be doing some cool projects. Like you're part of a design team, you said?
Yeah. So one of the things I am part of is the steel bridge design team, and that's just a student group. That's not actually like the major project that I did this summer. So essentially, what the steel bridge design team is we make a bridge that has like it'll have like certain specifications. So like you have to have like I don't know something weird like 2 skewed legs and just something to make the design a little more challenging. And it's a 1/10 scale bridge that will span over like a river. It's not a real river. It's just like a marked out area. And so essentially, you have to prefabricate a bunch of pieces. Like they can't be longer than 3 feet. It has to be a 20-foot span. And yeah, you have to be able to assemble it all. And it's like, okay, which bridge is like you test it. Which bridge is the strongest? Which bridge is the lightest? Which bridge can you build the quickest? So it's like actually like real construction skills alongside the engineering skills. And so one of the cool things about me for that was that a lot of the people there, they didn't have any of that welding experience. They had the equipment there, but it was like for me, like they were fortunate because like I know all the welding. I know how to like like I know how to sit there and set up a jig so you can make 10 pieces that are the exact same, right?
Mm-hmm.
So that was one of the cool things that I did at the U of S. I think another thing that's a lot more interesting is the research project I was working on for a professor this summer. That one was really interesting. So have you ever like seen like a concrete retaining wall?
Yeah, for sure.
Yeah. Okay, so we see those things and we always think that yeah, it's the concrete that's holding that thing up. That's a lie. It's just all aesthetic.
Mm-hmm.
So what actually happened, well, the old ones, it used to be the concrete, but nowadays what we actually use is something called geosynthetics. So what a geosynthetic is, it's a piece of plastic that we put inside of the soil that makes the soil pretty much stronger. I can go into more detail, but that's all you need to know. So the project that we had was a soil testing project. And so to test the soil, we needed a platform. And what better material to build a platform out of than steel, right? So this platform is gonna it applies a load, a 1 square meter load. So yeah, or no, the size of the load is 1 square meter, and it applies a load of 220,000 pounds.
Okay.
That's 100 tons. So that's the same as like 20 elephants. So a lot of weight we're talking about here.
75 of me. Yeah.
I hope not.
Well, COVID's not been great for my waist. That's why the camera only shows from the shirt up.
Oh, I got you. I got you. Yeah. So we had to design this platform. So I came in the second year. So they had the platform designed, but they needed some more welding, some more modifications, and things like that to it. So I had a relatively unique set of skills because like not only do I know how to do the welding, not only do I know like what materials will work together and all that type of thing, and like what bolts we should use, all that type of thing, but I also understand like the engineering side to it. So I can also design the things. And
then make them happen.
Then make them happen. So that's essentially what I did this summer. I like designed parts to this platform. I like drafted them. Like I used a program called SolidWorks. So I modeled it all in 3D, and then I made the engineering drawings, sent pieces off to get like laser cut, contacted suppliers, ordered parts, got everything organized, got it taken to a shop at
in Saskatchewan.
Yeah, at the U of S, and I actually put the pieces together with a crane, welded them, all that. So for that project, the things that they got me to do, which I think was pretty cool. So it's a 220,000 pound platform, and we're sitting there putting this load on the ground, testing the soil. They don't just want to do one test, right? They want to move the platform, do another test, move the platform, do another test. So what they were doing last year was they were like taking they drove trucks onto the platform, drove the trucks off the platform, moved the platform, and then put the trucks back. Yeah. So what they were like, okay, we want to add a wheel assembly to this. We want to make this rollable. So last year they did have a wheel assembly, but I guess one of the welds broke from the guy who was welding.
It
They
became
went to
it had one wheel less by the end of the day.
one wheel less, so it wasn't ideal. But so this year what we did was we used like a channel section, and inside this channel, a set of casters would roll inside the channel.
Okay, yep.
So we had 14 casters per side of the platform, so it was a total of 28 casters. And these were like heavy duty casters. Each caster was like 33 pounds, and it could support 12,000 pounds. So
Yeah, and actually, the caster technology. I was looking at FabTech last year. There's companies that invest heavily into roller and caster technologies because, I mean, they're very useful add-ons to a construction build because then things are easily movable. And now with the technology for casters, they can sustain a ton of weight and still roll freely.
oh yeah, like I was looking some casters, they're sitting there. It's like you can support 40,000 pounds with one caster.
Hmm.
That's insane.
And like the wheel doesn't deform, and like the plastic technology into the wheels is even amazing, right?
Yeah, so we actually didn't use plastic. We were using
Steel.
yeah, well yeah, steel. It was a cast iron. It was a nodular cast.
Okay, yeah.
So it does have a little bit of give in there, so it's not as scary as the cast, but
Well, that's nice. I like hearing young people say the word nodular. It makes me happy.
yeah. Yeah, I was looking at it, I was like, oh no, these are cast. I'm like, well, what type of cast?
Yeah, because if they're the wrong kinds, they'll just smash, right?
Yeah, because you saw some gray cast iron, I'd be like, oh, I don't know about that.
Hmm.
Yeah.
So then you helped build these sliding platforms now that they can move them around easier. And so did that speed up the testing ability like substantially?
Well, so the project's still in progress now, but like I'm sure it's going to, because so I built these caster assemblies, installed them, and I could actually show you them if you want. I could share my screen. I have some pictures here.
Yeah, I can give you power. That's for sure. Like, I mean, it's an audio podcast, but we do release this on YouTube for the people that are interested. So if anybody wants to check it out, yeah, go onto the YouTube and follow up with this. Yeah, you should be able to now, buddy. So for the people that are listening, the screen is coming up.
Okay, can you see this?
All right. So this is the U of S shop that you're showing me here?
Yeah, this is the
That's
structure as well.
okay. Well, that's a lot of space. You know, it's a cool spot that you guys have there.
Yeah, and they have an overhead crane here that can can lift all the pieces for us, so it's pretty cool.
Mm-hmm.
And so as you can see, I'll just kind of try to describe it here. So essentially what I did for this assembly, and like the design like was completely like I did it on my own. Like there was like I had some supervision saying, yeah, maybe you should do this, maybe you should do that, but like all the sizing, all the welding, like how much weld this needs, how much, all that type of thing I did on my own, which is pretty cool.
That's
So
awesome.
essentially what I have here is I have two pieces of HSS. They're 24 feet long, each of them. They're 6 by 6 by half. And they're stitch welded along the length. And so then what I did to the HSS is I have two pieces of angle iron welded on either side of the HSS.
Mm-hmm.
And now onto that.
That becomes the mounting. Yeah.
Yeah, those are like the mounting plates. And so then for those mounting plates, now I can screw on a flat plate on top of it. And that flat plate has nuts welded onto it. And the HSS has holes drilled into it so that the nuts can fit through.
Mm-hmm.
And so now, like if you ever want to replace those nuts, all you have to do is just take off the plate.
And it's all fixable and accessible.
Yeah, it's all accessible. And so then just to put on the casters, you can just like bolt one off, bolt one on, bolt one off. So they're completely replaceable and interchangeable. And so,
if you have a spare set in case something blows out, you could even have a spare set that you could switch out quickly.
Yeah, for sure. And that's what we ordered a couple extras. So
good.
And so as you can see here on the left here, there's a piece of channel section. Each of these channel sections, they're a modular system. So each channel section can bolt together there's pieces of angle iron welded onto either end of the channel section. And there's a flat plate underneath the bottom that's a little bit offset just to kind of increase the stiffness on the connection point.
Yeah.
Yeah, so that's generally how that works there. And
And so that's out in the
so
field this summer. Did they work on it, or did COVID kind of slow that down, or did that continue?
it's still going, yeah. So COVID slowed us down at the start, which kind of put me in a real time crunch because initially I had 4 months to do this whole project. Now suddenly it's like 2 months. Now it's like 1 month. So I did this whole thing in like just over a month. Sitting there working 12-hour days because it's like, okay, I don't want to be doing this during school. So I got it done, like true welder attitude.
Yeah, and so this research project was under who and for who?
The research project was under Dr. Fleming. He's a he's one of the main soil mechanics teachers. So he's a geotechnical engineer, or I think he might be a either geological or geotechnical engineer. And we were working for a company from the States, a geosynthetics company called Tensar.
Okay, so this falls under an applied research project then.
Yeah, an applied research project for sure.
That's awesome. And in Saskatchewan, I think, and for most of Canada right now, there is a big push to try to get applied research projects off the ground. One of the big stumbling blocks that we have in Canada is that there isn't a lot of government support for research projects anymore. Where 30 years ago when I was coming up in the welding industry, the government invested heavily into research projects. That's not a thing anymore. But if you can find the private partner like you have, the private partners, they're the ones that have to step up now to get these research projects off the go. And the amount of data that you'll pull out of it, yourself, your team, the college, and the company, is invaluable. It really is, because it's the data you accumulate is transferable to so many other sectors, right?
Oh, 100%. And like some of the research that they're doing, it's like it's brand new. No one's done this before, right? No one's really done this. Like this is full scale testing of geosynthetics.
Hmm.
Like previously, what they would do is they just have like a scaled down thing in a lab where it's like
A
one
guy
tenth the
standing on
scale.
it.
Yeah, pretty much. And it's a lot different because in soil mechanics, a big thing about the soil is it's not the same everywhere. So
Yeah.
if you do it in a scaled down piece, it's a perfect scenario. That's not how it's going to work. There's little small cracks in the soil. There's little small like there's different things that you can only really capture with full
Different
scale.
densities of materials. Every foot that you go, it changes.
Yeah, 100%. 100%. So
Well, how
it's
compressible is soil? Like, you just look outside, you think of the earth, and you think about how compressible it is. Well, how much will 220,000 pounds compress over 1 square meter?
it really depends on the type of soil. It really depends on the type of soil.
Hmm.
And it also depends. So like what we're doing here, like this can increase the load that the soil can take to like this is yeah um 1,000 kilonewtons. Okay, I don't know if you know what that means.
Yeah,
Maybe you'll
yeah.
convert that.
1,000 kilonewtons. So a kilonewton is based off of gravitational pull. So that is
So
so right.
yeah, so I guess that's yeah. So 220,000. Yeah, it is. Yeah, it works up to 220,000 pounds.
Hmm.
So it could hold up to 220,000 pounds. Without this geosynthetic in there, now the soil's only gonna hold like I don't know, like probably
Like a tenth of it or something. Like
50,000 pounds around
yeah,
there.
yeah.
And
Or it starts
this
to
is
like
actually
collapse.
yeah, and this is actually like useful in like the construction industry for like even like welding projects too, because like you got to get a big crane out onto some super weak soil that's just gonna sink in. How do you do that?
Yeah.
Well, you're gonna use these geotextiles, right? Which gives you the stronger strength.
So a geotextile, for the people that are listening, can be a number of different materials. The geotextiles that you guys are using in your testing, what's the main base ingredients for these ones?
So they're a polymer. I don't know the exact polymer, but
Okay.
so the geotextile that we are using is called the geogrid. So what that is just looks like a piece of mesh.
Mhm.
And what this piece of mesh does is you put this piece of mesh in the soil, you put some coarse aggregate, so like gravel,
Yeah.
pretty much. You put gravel, you put this grid, and you put more gravel. And what the grid does is it like stops the gravel from sliding on each other. So it kind of locks the gravel together and gives it like a stronger,
Yeah.
higher strength.
Kind of like the lattice inside of a steel structure, right?
Yeah, exactly. Same general
Principle.
concept. Yeah.
Awesome. Well, that's super interesting. What's going to happen now in your last year? Do you got something else you're going to start working on? Or are you just going to buckle down and graduate, or is there other projects you got going on?
Buckle down and graduate. I do have the opportunity to do more on this project, but I'm gonna play it by ear first, see what comes up, see when I graduate. Like it's a super cool project. Like sitting there being able to like build things that are like like each piece is like 2,000 pounds, and you got to figure out like you're out on site with what's it called, with an excavator,
Mm-hmm.
sitting there trying to line pieces up. It's super cool, but they do have like this testing is going to keep going on for, I would assume, many years to come, and they do have like other testing projects that they want to go ahead with. Like I know they want to try to replicate the load that's experienced on roadways with like a wheel, so that's like a whole new type of challenge. But for now, my plan is just to graduate, maybe get some more engineering experience, because this, like, for sure, this is engineering experience for me, but there's still a lot of welding experience in there too, right?
Yeah. And also in this research project or at the college, the engineering experience you get is very formulated. It's very structured.
Right.
Whereas
Right.
we're in the industry, if you go to a shop, you're going to be in a lot more hairy situations that you have to think on your feet. And that's
Yeah, for
fun.
sure.
And that's good for you, right?
100%, 100%. Because you can sit there and you can learn all the bookwork you want, but at the end of the day, you have to like actually, like
Quiet.
use your problem solving skills.
Yeah. Well, awesome, Rob. Is there anything else you want to talk about? Because this has been super interesting for me.
Um, I don't really know if I have much more. I could tell you a little bit more about the other things that we got to do with the platform.
Okay, yeah, I'd like to hear about that. Sure.
Sure. It won't be long, it'll just be a little bit here.
Yeah.
But so we built this wheel assembly, right?
Mm-hmm.
Another thing that we did with the platform was there were there was a structural review, and so the reason why we had to do a structural review is because like this platform now has to take a higher load because they're testing stronger geo grids, right? So then I also got to reinforce some top and bottom flanges, which was cool, and I also got to make like a cross bracing system for the whole bridge, which was pretty cool. So we used like pieces of angle iron with what's it called, with like little flat plates to connect it.
The fish plates, basically. Yeah.
Yeah, that was another cool thing.
Well,
But aside from that,
no, go ahead.
that's
Yeah.
yeah. Aside from that, that's pretty much all we did on the project this summer, which was.
Well, one of the reasons I was really looking forward to having you on the podcast, and I think you've proven me right yet again, is that it's something that I preach to young guys coming up all the time, young welders, girls, whoever, is that the welding trades, the spectrum of welding and steel work is huge, right? Right from the person who's pulling the trigger on a MIG at a fabrication shop, to the engineers, to the service staff, to the shippers and receivers, and the saw guy, and the material handlers, and sales, and machine maintenance. Like, I mean, there's so many avenues of work that are valuable in the welding industry. And having that first year of school, even where you go get welding level 1, that isn't even enough to kickstart you in a whole new spectrum of work, right?
Oh yeah, for sure, for sure. There's like, and I'm realizing it even more now. Like there's so many people who know so many different things, and there's so many different things you can do with welding experience, welding knowledge.
Mm-hmm. Well, awesome. Well, thanks a lot, Rob. That was a super good interview. I really appreciate it. I'll probably check in with you closer to your grad time to see what's going on.
Sure.
Maybe bring you back up and see what's going on. I'm very interested to see where your career goes in the future. It's something I've actually, in the last few weeks and during even this COVID times, I've been kind of following up with some students. I went and visited a student's shop last week, and he just expanded it. He's 21 years old, and he has a 15,000 square foot shop, and that's all by himself, and that's awesome. I love seeing stories like that, and like yourself.
Was he in my year?
No, he went through innovative manufacturing.
Oh, okay.
He was in my first group, and he basically graduated and immediately started a business and in Moose Jaw Metro Manufacturing, and they're doing awesome. And he's just a young kid like you, works his ass off, and I love seeing it. It's awesome.
That's awesome.
Yeah,
It's
maybe you
inspiring.
can talk to him.
What's
You guys
that?
can get. You should talk to him. Maybe you guys can get some type of deal going.
Yeah, that's what I was actually just thinking. Yeah.
Yeah, no, he's got lots of cool stuff on the go. He's very creative. So, all right, well, that's it. For everyone that's been listening, if you got any questions for me or Rob, our information will be put up at the end of the podcast. Also, check us out. These podcasts get released on YouTube, so they'll be on Spotify probably next week. Keep paying attention. I'm recording lots of shows right now, so there'll be lots coming up in the next few months. Hopefully, one a week. So, thanks a lot, Rob,
Thank you very much, Max.
and then take care, buddy.
You too.